This lesson is going to be about expanding brackets. Our learning objectives are to understand what it means to expand brackets, to be able to expand brackets using repeated terms or rectangle areas, and finally to be able to expand brackets using the distributive law. Let's begin this lesson by talking about Finn's backyard, which has both a concrete and a grass area. So here's the concrete area and here's the grass area. Now we know that the width of Finn's backyard is 4, but we don't know what the length is. We know that the length of the concrete area is 3, and we know that the length of the grass area is 6. So if we were asked to find what the concrete area is, we know that's simply length times width. So for the concrete area, that's going to be 4 times 3. 4 times 3, which is going to be equal to 12. And we're not going to worry about putting units in for this question. Let's now move on to the grass area. And again, this is simply going to be length times width. So in this case, 4 times 6. 4 times 6, which is equal to 24. Finally, we need to write two equivalent expressions for the total area. Now, one way we could do this is simply adding together the area of the concrete and the area of the grass. So that would be 4 times 3 for the concrete, and then plussing that with 4 times 6 for the grass. 4 times 3 is 12, and 4 times 6 is 24. 12 plus 24 is 36. Is there another way we can do it? And there absolutely is. If we're given just one rectangle, if we think of this as just one rectangle, we could figure out what the area is by simply going the width times the length. So the length of the entire thing. So what is the length of the entire thing? Well, it's simply going to be 3 plus 6. So I'm adding together the length of the concrete and the length of the grass. So 3 plus 6. Now I'm actually going to leave it like this. I obviously could write 9, but I'm just going to leave it as 3 plus 6. So now to write an equivalent expression, I'm going to go my width times my length. So 4 times 3 plus 6. So we can write that like this, 3 plus 6. Now, hopefully you remember your distributive law, which we learned a few lessons back, which told us that if we have a number outside some brackets, it's going to multiply with the numbers inside the brackets. So we're going to distribute this 4 to what's inside. So it's going to be 4 times 3, and because there's a plus here, then it's going to be plus 4 times 6. So I could grab my pen and I could write 4 times 3, 4 times 3, plus 4 times 6, 4 times 6. Now, as you can see, this and this, they're the same. Now I could go 4 times 3, that's 12, and 4 times 6, that's 24. And if I plus those together, I'm going to get 36. And as you can see, that's the same as what we got on our left-hand side. And that's because they're equivalent expressions. So everything that we've seen on this slide is stuff we've seen before. Let's now introduce our algebra into this. So now we're looking at Billy's backyard, which has both a concrete and a grass area. Billy's backyard has a width of 3. We don't know yet what the length is, but we know that the length of the concrete area is 2. And we actually don't know the actual length. So let's now look at Billy's backyard, which has both a concrete and a grass area. The width of Billy's backyard is 3, and we don't yet know what the length is, but we do know that the length of the concrete area is 2, and the length of the grass area is A. So if we were asked to find what the concrete area is going to be, it's simply going to be the length times the width of the concrete area, so 3 times 2, 3 times 2, which is going to be equal to 6. To find the grass area, it's again going to be length times width, so 3 times A. 3 times A, which is going to be equal to 3A. Finally, we need to write two equivalent expressions for the total area. So the first way we can do this is simply adding together the concrete area and the grass area. So that's going to be 3 times 2 plus 3 times A, which will be 6 plus 3A. And that will be my final answer, 6 plus 3A. It can't be simplified any further. Now, what's the other way I could write it? Well, just like before, I could add together the length of the concrete area and the length of the grass area. So that's going to be 2 plus A. So that is going to be the length of the entire backyard. So now that we have the width and we have the length of Billy's backyard, I could simply times these together to get the total area. So that's going to be 3 times 2 plus A. Now, just like before, we're going to utilize our distributive law, which tells me I can go 3 times 2, then plus that with 3 times A. So I can write that out now as 3 times 2, 3 times 2, and plussing that with 3 times A. 3 times a. And then I could write this as 3 times 2 is 6 plus 3a. And as you can see, I've gotten the same on both sides, which makes sense because they're equivalent expressions. Now it's your turn to do some maths. So I want you to pause the video and see if you can answer these two questions. So pause the video and give it a go. So how did you go with this question? So what we need to do is write two equivalent expressions for the area of each rectangle shown, only one of which includes brackets. So let's look at this one first. So if I want to write an expression of the total area, I could simply go 2 times 5 to get the orange area, which is going to be obviously 10. And then to get the blue area is just going to be 2 times x. 2 times x, which is 2x. So one way that I could write my answer is 2 times 5 plus 2 times x, which is the same thing as 10 plus 2x. The other way I could do it is by finding the total length of the rectangle, so from there to there, which is obviously going to be the length of the orange part plus together with the length of the blue part. So 5 plus x. 5 plus x. Now I can simply do length times width of the entire rectangle. So that's going to be 2, 5 plus x. So there you go. There are your two equivalent expressions, only one of which has brackets. So how do you now go with the second one? So to answer this, we're going to do the same thing. The area of the blue part is obviously going to be 12 times a, which is equal to 12a. And the area of the orange part is going to be 12 times 3, which is going to be 36. If we now need to write two equivalent expressions for the total area, I could simply add the two parts together. So 12 times a plus 12 times 3, which is going to be 12a plus 36. Or what I could do is plus together these two lengths, so 3 and a. So that means the length of this right here is going to be 3 plus a. And now I simply need to go this times this to find the area of the rectangle. So 12 times 3 plus a. And now what we've done is we've found the two equivalent expressions of the area. Let's now answer some questions which are very similar, which you're going to see in your exercise in your textbook. So again, we need to write two equivalent expressions for the area of each rectangle shown, only one of which includes brackets. So to do this, I could simply add together the area of each portion. So this is simply going to be a times b, so a, b. This is going to be 2 times a, so 2a. Well, if my pen wants to work with me here, 2a. This is going to be 7 times b, so 7b, and here is going to be 7 times 2, which is going to be 14. So therefore, my answer for one of them could be ab plus 2a plus 7b plus 14. So just to recap how we got this, what I did is I went length times width for each rectangle. So here I went my length times my width. Here I went my length of a times my width. So I'm doing it 4 times to find each individual one. Now, the other way I could do this, instead of finding it for each individual rectangle, I could simply plus together to get this side. So I'm going to plus together b and 2. So that's going to be b plus 2 for this side right here. And then I could go to get this side. I could go 7 plus a. So 7 plus a. Now, I would simply need to times together these to get the area of the whole thing. So that's going to be b plus 2, brackets, brackets, 7 plus a. And those are going to be your two equivalent expressions. You should now pause the video and see if you can answer this one for yourself. So let's now do it together. So we again need to write down two equivalent expressions for the total area. So to find this one, I'm going to go my width times my length. So 6a is going to be the area of this one. This one's going to be 4 times 6, which is 24. This one is going to be 4 times b, 4b. And this one is going to be a times b, ab. So what I did is I found each area by going the length times width 4 times, each time for my each individual area. So I'm doing it 4 times. So it's going to be ab plus 6a plus 24 plus 4b. Now what we're going to do is find what the total length is going to be and find what the total width is going to be. So to find what the total length is going to be, I'm simply going to plus these two values together. So it's going to be 6 plus b. And to find the total width, I'm simply going to go 4 plus a. So 4 plus a. And now I need to times these together to get the total area. So that's going to be 6 plus b times 4 plus a. Now, hopefully you can see something that often happens in maths, and that is when we're dealing with algebra, sometimes it's hard to tell apart our b's and our sixes. So if you were to look at these, which one is my 6 and which one is my b? So you need to be really careful when you're doing this to make sure that they're distinguishable from each other. So let my 6 look like that, and my b look like that. That looks a bit better. But hopefully you can understand what we did here. So you can either do your length times width 4 times and then plus together all your results, or you can find what the total length is and find what the total width is and simply times those together. Now, everything we've been doing so far in the lesson has been background information to our topic of expanding brackets. So expanding brackets involve writing an equivalent expression without brackets. This can be done by writing the bracketed portion a number of times. So as you can see here, we have 2a plus b. So that simply means 2 times a plus b. So I'm going to have 2 lots of a plus b. So here's a plus b. So here's a plus b plus a plus b. So I simply have 2 lots of a plus b. And then I can gather my like terms. So I have 2 a's, which become 2a. Then I have 2 b's, which become 2b, which we saw in our last lesson about like terms. Now, the other way we can think about it is by multiplying each term by the number in front. So if I have 2a plus b, that means I have 2 times a and 2 times b. And then again, I'm simply going 2 times a, that's 2a, and then 2 times b, 2b. So I'm just getting rid of the multiplication sign this time to get to this point. And this is really what we've been doing with the distributive law. So to eliminate brackets, you can use the distributive law, which states that, now here we have something important, and you should have been taking notes for this entire lesson, but now you need to make some important notes right here. What I need you to do is put in some lines. So there to there, and there to there. So these lines are distributing out this a for me. So a times b, then a times c. So a times b plus a times c. And over here, we can do the same thing. Put in those lines, which are telling me a times b, but this time minus a times c. So this is our distributive law, and we use this to eliminate my brackets. So as you can see here, we have 2 equivalent expressions, but one of them doesn't have any brackets. So we say we have eliminated the brackets. The process of removing brackets using the distributive law is called expansion. So if I asked you to expand these brackets, this is what I'm after. Let's now work through some examples. So we need to expand the following expressions. And here we have 8a minus 4. So I'm going to distribute out this 8, and I'm going to be left with 8 times a, 8 times a, and then minus 8 times 4, 8 times 4. I know that 8 times a is 8a. Then I have this minus, and 8 times 4 is 32. So that is going to be my answer to the first one. Then next I have 9x, then times 3z minus 2. So again, I'm going to distribute out this first term. So I'm going to get 9x times 3z. Then I'm going to minus 9x times 2. So 9x times 3z, that is going to be 9 times 3 is 27. Then I'm going to have an x and a z. Then I'm going to minus 9 times 2 is 18. Then I have this x. And that is going to be my final answer there, because they're 2 unlike terms. They're not like terms, so that's where I'm going to leave it. So hopefully you got those answers. I now want you to do some expanding on your own, so could you pause the video and give these a go? And notice the fact that after you've expanded them, I want you to evaluate for a equals 2, and then over here for a few others. So give this whole thing a go, and then click back to see if you got the right answer later. So let's quickly run through these. So I'm going to distribute out my 3, so I'm going to get 3 times 5a. Then I'm going to plus that with 3 times 2. That's going to be 15a, and that's going to be 6. Then let's stay here. I can't do anything more. They're not like terms. But now I want to evaluate for a equals 2. So that means I'm letting my a equal 2. So instead of an a, I'm going to put a 2 in that spot, plus 6. Now that's going to be 15 times 2 is 30. then I'm plussing 6, so it's going to be 36. Now, the reason why I want you to do this evaluation is because I want you to appreciate that we're going to get the same answer whether I put it into this expression or this one up here. So for instance, if I was to let a equal 2 for up here, I'm going to get 3, then 5 times 2, then plus 2. Now, that's going to be the same thing as 5 times 2 is 10 plus 2. So it's going to be 3 times 12, which is the same thing as 36. So as you can see, even in my expanded form or in my bracketed form, it's still going to get me the same answer. Let's now go through our final example together. We have 5a, then 3p minus 7q. So again, I'm going to distribute out my 5a, which is going to give me 5a times 3p minus 5a times 7q. Now I'm going to get 5a, that's going to be 15ap minus 5 times 7 is 35aq. So that's where I'm going to leave it. So let me actually put boxes around my final answers here. That is the ugliest box I have ever seen in my life. Let me try that again. There we go. That's a pretty ugly box, but it will do. All right, now I want to evaluate it. So a equals 2, p equals 1, and q equals 3. So every time I see an a, I'm going to put a 2 in there. So that's going to be a 2. Then every time I see a p, I'm going to put a 1. Then I'm going to minus 35. I'm going to put a 2 there. And then my q is 3. So I'm going to go 15 times 2 times 1. That is going to be 30. Then over here, I'm going to get 35 times 2, that's 70, and then 70 times 3, that's 210. Now I have to subtract these from each other, and what I'm going to end up with is negative 180. There you go. So that's quite a hairy looking number. But let's now show you that I'm going to get the same answer, the same hairy answer, even if I put in my numbers up here. So let me now do that. So I'm going to get 5, and then I'm going to put a 2 in. Then I'm going to have my brackets 3. P is 1, then I'm going to minus 7, and Q is 3. Okay, 5 times 2 is 10, 3 times 1 is 3, minus 7 times 3 is 21. Then I'm going to go 10, 3 minus 21, well, that's negative 18, and 10 times negative 18 is going to be negative 180, which is the same thing that we saw over here. So let me give that a bracket, give that a square as well. So that's down here, this evaluations. I just really wanted to show you that whether or not you're using the expanded form, when you're substituting in numbers for your pronumerals, you're still going to get the same answer. So hopefully you got all that down, but the most important part is that you understand this expansion part. Let's now review what we've learned in this lesson, which has been all about expanding brackets. Hopefully you understand what it means to expand brackets. To be able to expand brackets using repeated terms or rectangle areas. We spent a long time on that rectangle areas. And finally, to be able to expand brackets using the distributive law. So we did a few examples at the end about that. So hopefully you feel comfortable with this content. To improve your skills, you should now complete the homework allocated for this topic. Good luck.